Hey guys, I intended this channel when I first began to sort of be me learning to solve a LeetCode question and then giving a tutorial, but I figured I really still suck at this and would just use this as an archive to kind of see how I struggled and to look back on solving problems. So until I get good, I think I'll just try and solve problems and just document the types of struggles I went through as I solved these problems. So today I'll solve 160 intersection of two linked lists. Never solved this problem before, and here we go. So given the heads of two singly linked lists, head A and head B, return the node at which the two lists intersect. If the two linked lists have no intersection at all, return null. So this is an example. Let's see. So A is connected to A2, but then the two linked lists are connected to the same linked list afterwards. Custom judge. Okay, there's these custom judge values of nodes where the intersection occurs. Skip A. Pass the two heads to your program. Okay. The description's slightly complicated, but I guess so, but you have to return a list node. So you're not really returning whether it's true or false that they intersect. Is correct. Okay, so if it intersects, return the node at which they intersect. Okay. And if it doesn't, we just want to return null. Okay. So I guess my approach is so first vague thought I get is if we traverse through both linked lists, so we go from A1, A2, C1, C2, and C3, and then B1, B2, B3, and C1 and C2 and C3. So I guess if we traverse both at the same time and try to find where it intersects, there could be a problem because for A, C1 is a third node they meet, whereas for B, it's the fourth one. So in theory, if we're looping through both of these and we're not storing the nodes that we've seen, I guess it's impossible to determine that they meet at C1. So, and they have to retain their original structure. So, okay, since we just wanna return the intersection, I'll go ahead and initialize this as none and return intersection at the end. I always do this. I just initialize the output and the return statement at the end. So I think my approach is to store all the nodes in scene. And if they overlap, you assign that node to intersection. I wonder if all the nodes are unique. So, okay, follow-up is using O1 memory, so there's definitely a way to do it, but I'll start by using a scene. So what I'll do is I'll initialize a set, hash set, where I'll store all the nodes that we've seen. And how are we gonna do this? So while since we want them to retain their original form, I'll just create a reference. So while node a dot next and node b if or node b in scene. So if you find that either node A or node B is in scene, yeah, because so if node A is in scene, we can just return node A because that's the node of intersection. And if node B in scene, we want to return node B. But if they're not in scene, we want to dot add B. So let's test this out. So for the first example, on the first iteration, there's both node A and B, and none of them are in scene. So we just add node 4 and node 5 to scene. And we're not passing in the values, so I guess because each node is unique but can have same values. So look here, this node and this node is completely different, but they have the same values, so I want to store the node, not its values. So on the first iteration, we just add and then move on. Oops, there's a typo here. And on the second iteration, we're adding node 1 and node 6. So on the third iteration, we're adding node 8 and node 1. But this won't trigger anything because although the values for these two are the same, they're different nodes. and this is where you should return. So when you add node 4 and then we're trying to add node 8 here, we see that this is actually in the scene already, so should return node B. And I actually realized that we don't really need the intersection. We can just return none if the loop terminates. Let's try. Okay. So what's the problem here? Cannot access a local variable node where it's not associated with a value. Cannot access local variable. Oh my god, I'm so stupid. Let's see if this works. Oh no. So I actually returned that there's an intersection at 4. Which is kind of weird. Let's get case 2. So it's supposed to intersect at 1, but instead it said, I mean, it's supposed to intersect at 2, but it said it's 1. So I guess the problem here is that I think I know why. So for here, when B is first looking to put in 8, A actually accesses 4 again, and I guess that's a problem because A already has 4 in it. I thought set was a... So yeah, maybe I'll create 2 sets. So scene 1, scene 2. So scene 1 would explicitly contain the nodes that A has seen, and scene 2 would exclusively contain the nodes that B has seen. So if node is in scene 2, there's an overlap. Scene 1. Let's try this out. Okay, now time limit exceeded. Okay, I don't know where I'm going with this, so let's try to figure this out again. Okay, I see why now. Because we aren't actually moving up on the list. I mean, on the linked list. Okay, B equals node B dot next. So would this work? Yep, gotta fix this. Please. Okay, it works for 2 cases. So it works for the first one and the third one. But somehow there's a problem with the second case. Let's see what the problem is. So mine said there's no intersection, but it actually intersects at 2. Wonder why. So let's test this out with 2. So 1, 9, 1, 2, 4, and 3, 2, 4. So we put, so if because for the first element, none of them are in scene, so we just put them in 3. Okay, on the second iteration we do 9 and 2. Third iteration and we do 1 and 4. Oh, and then the loop just ends because there's no more node B. So if we do this, okay, this is kind of ugly, but we'll try. Yep, because it goes to none. So if node B, node A. I'm sure there's a better way to write this, but for now, this is all I can think of. And we don't want to do, like, put none in, so we can actually just put this here and put this here and run it. Smooth. Yeah, try submitting. Okay, there is a problem. So mine says there's no intersection, but this one should have an intersection at 4. So for this one, let's try this out. There's 2, 2, 4, 5, 4, and there's 2, 2, 4, 5, 4, and the intersection is 4. So just add 2 and 2, 2, another 2 and 2, and then we okay, the problem is, I guess, that we're checking first and then adding it. So when they both added it, okay, wait, they checked first whether 4 is in the scene. They're not. So they added 4s in there. So essentially, so we want to add, okay, check add is how we're supposed to do, I think. So we check, then we add, and then we check, and then we add. I think that's the strategy here. Let's try. Nice. And there we go. Thank you guys for watching this video. Please like and subscribe.